Kia ora and welcome to this introductory video on the states of matter. What is matter? Well, matter is made up of these tiny microscopic atomic particles known as atoms. Atoms comprise absolutely everything in our universe that is considered matter. There are a number of different types of atoms and we'll get into that in a different video. Today I want to explain how these atoms interact in different states. Now you'll have all seen the three main different states, and some of you may have even seen the fourth state of matter. So what are they? Well, firstly we have what you and I are, or part of us is, and when you whack your knuckles on a table, it is a solid. The second type, you've all had a bath, hopefully, and that is a liquid. And finally, we're all breathing right now, and that is because there is gas in the air around us. So we've got that last one of a gas. So, interestingly, you can go from one to the other. So how do we go from one to another? You need one very important ingredient, and that is energy. To go between the three main states of matter, that form of energy that is often used is heat, or the lack of heat. For example, to go from a solid to a liquid, and let's take an ice cube as an example. Ice cube is solid water. To go from an ice cube to a liquid, we know we just need to leave it out in room temperature, because for water at 0 degrees Celsius, it is a solid. Any temperature above that, it'll start to melt. And the process of going from a solid to a liquid is known as melting. Once we are a liquid, we know, if you want to make a cup of tea, that you need to increase the heat again, much more than room temperature this time, to about 100 degrees Celsius. Once you start doing that, you start to evaporate the liquid. And that is the process of going from water, liquid, to water, vapor, a gas. So that word again is evaporation. Now, to go the reverse way, we do the very similar thing, except we take away that heat. We cool the system. So, you'll often see in the morning, if you breathe on glass, your breath, the water vapor in your breath will start forming droplets on a window. Now that is known as condensation. Condensation is the cooling down of the molecules, and then they clump together to form water droplets. Now, to go from a liquid, and lots of you'll do this in the summer, will want to cool the drink bottles down, so keep them cool, put them ice cubes in them, will put their drink bottle in the freezer and bring that temperature even further down, remove more heat from it, and that is known as freezing. So, we now know the three main states of matter and the common ways that we go about going between them. But what's happening to the molecules at this state? We're going from solid to liquid, but what does that actually mean for the atoms? Well, I'm telling you that all atoms are moving, regardless of if they're solid, you can't see them moving, or liquid in a drink. They are constantly in motion. Here, they're just vibrating a little bit. Here, they're allowed to move a lot more. And in a gas, they're shooting all over the room. Now, molecules and atoms move in random directions, and they go in a straight line until they come into contact with each other or another thing. If they come into contact with each other, they will either react or bounce off each other, and that's how things move around the room. If you fart in one corner, your friends will eventually smell it, because the particles, whilst being concentrated in that corner of the room, will eventually spread out through random direction until your mate in the corner smells it. So, what does that mean with heat? Well, heat is a form of energy. Now, I know if I went and gave all of you a Red Bull, it'd be extremely hard to teach you, because you'd be all bouncing off the walls. The analogy is similar for the energy in a solid. By adding energy to a solid, to our ice cube, we're giving those molecules more energy, which means they move more, they vibrate more, they start to break the weak bonds that they have between each other, because all atoms are attracted to each other in a certain, all matter has a gravitational effect on each other. So they start to break apart those little bonds, and then they start being able to move more. If they can move more, they become a liquid. If you increase the energy even more, they then start to bounce right out of the system and can leave the vessel, like the glass with water. If you're boiling a beaker on a Bunsen burner, it'll start evaporating and going out of there. Now, you'll notice I've left this box down here. What is the last state of matter? Well, some of you might know, it is plasma. That's my attempt at drawing one of those cool little globes that you can touch and all the electric current goes through to it. That is plasma. And the way you go from a gas to a plasma is to add energy, but a different form of energy. Here you need to add electricity. Or the form of electricity that we're talking about is ionization. And to go back from plasma to a normal gas is deionization. So, the fourth state of matter is plasma. Where do we see this? We often see it in the fluorescent bulbs, the long ones. The ones in our classrooms are now LEDs, but they used to be charged, I think it was phosphorus gas, so they're not very good to break apart. So, here we have the four states of matter. We now know that if you add energy, it increases the movement of the particles. If you take that energy away, it slows them down. Okay? Really important to remember that. Energy means more movement. Movement means the particles are able to move around more. The more they can move around, they'll start to slowly break the surface of the water tension and become a gas. Now, those that are observant will have seen there are two arrows that I have not filled in yet. Now, it is possible to skip steps from a solid to go straight to a gas. And you see this often with dry ice. If you drop dry ice into a bucket of really hot water, it'll instantly vaporize and you get this really cool big cloud of gaseous carbon dioxide. It's this big sort of explosion, really cool to look up on YouTube. And likewise, you can go from a gas straight through into a solid as well. And those two processes are known as the following. To go from a solid to a gas by increasing the amount of energy very, very suddenly, it's called sublimation. And finally, to go from a gas straight into a solid state, it's called deposition. So, there you have it. In summary, there are three main states of matter: solid, liquid, and gas. There is a fourth state in which if you charge particles of gas, they become plasma. You may have done that in the microwave with grapes. To change the states of matter, you need to add or take away energy. All of these and everything that is matter is made up of atoms. Atoms are constantly moving. The more energy you add, the quicker and the more vigorous they will move. The more energy that they get, the more they move, the more the solid shape of a solid will start to change into a liquid, which can then be manipulated differently to a solid by being poured. And finally, when those molecules get enough energy, they will start to escape the attraction of one another into whichever space they're in. Finally, there is an ability to jump between steps, and that is known as sublimation and deposition. Hope you found this video informative. Any clarifications that I need to make a note of them now. Come and see me in class.